All right, let's see how we do to solve this type of rational inequality. Uh, First thing we want to do is make sure that whatever we're comparing our unknown side to, we are comparing it to 0. That's the most important thing, because when we're comparing something to 0, we can decide whether it is bigger or less than 0 based on whether it's positive or negative, right? Every positive number is more than 0. Every negative number is less than 0. So this is an easy decision to make. But when you're comparing it to 2, that's not as easy. So the first thing you need to do to make sure this is well posed, this is an easier question to solve, is make sure that one of the sides of your inequality contains 0. So I'll start by writing this left-hand side right here, and then subtracting the 2, and that is less than or equal to 0. The reason why I left a little bit of space in here is because I know that for me to group these two together, right? Remember, I'm trying to decide whether this is positive or negative, so it's a lot easier to decide whether a fraction is positive or negative than if a subtraction or if a difference is positive or negative. So what I will do is I will find a common denominator for these. So these, this 2 I'll multiply by 3x plus 4 over 3x plus 4. And it turns out that this turns into minus 6x minus 8 divided by 3x plus 4 less than or equal to 0. And then grouping the x's, that's minus 8x. Grouping the numbers, 4 minus 8, that's minus 4. 3x plus 4 less than or equal to 0. So now the problem we had before is reduced to a simpler problem. When is this thing negative, right? When is this thing negative? Of course, we are allowing it to be 0 as well, but checking if it is negative is also a possibility. So let's see, when is this thing negative? Whenever two numbers dividing each other have different signs, so one is positive and the other is negative, doesn't matter which one is positive, which one is negative, as long as they have different signs, the result of division is negative. So that's what we're trying to understand. So let's look at the, so let me save this. Right, this is going to be my provisional new problem that I need to solve, and then I'll analyze the numerator and the denominator separately. So what is this guy, right? This is a decreasing line. The graph of this is decreasing line, and the root of this, right, the place where this crosses the x-axis, can be found like that by solving this equation. So x is negative 1/2, and so if I were to graph that, that would be a decreasing line at negative 1/2. So that means for every x value to the left, the y would be negative, and for every x value to the right, the y would be the other way around, right? Let me say it again. For every x value to the left, the y would be positive, and that's because the graph is above the axis, right? The graph is above, so we have positive y values, and here we have negative y values because the graph is below. Okay. So we're going to repeat this reasoning with the denominator of the fraction. So I'm going to split this up and repeat that with 3x plus 4. So when y equals 3x plus 4, the graph of this is instead an increasing line, right? And 3x plus 4 equals 0 when 3x is negative 4 and x is minus 4/3. Minus 4/3 is more negative than 1/2, right? 1/2 than negative 1/2. Negative 1/2 is negative 0.5, so it's closer to 0 than negative 4/3, which is negative 1.33, right? So the fact that this is increasing makes it so that this is negative. The y values are negative all the way because the graph is below, and the y values are positive all the way because the graph is above, and this cutoff point, the changing point where it crosses the x-axis, is minus 4/3. So finally, what do? I put these two pieces of information together, right? Minus 8x minus 4, and then 3x plus 4. I put the two numbers in order, so I need minus 1/2 here and minus 4/3 in here. Remember that this is less negative, right? So it's further to the right. I put my signs in there. So I have pluses in here, negatives in here, and then negatives in here, pluses in here. And then I think of the result. Again, I repeat my numbers. And then I start reasoning about the signs of each of those. So what happens when I divide this by this, which is that, right? I'm dividing a positive by a negative, so my answer will be a negative. Here I'm dividing a positive by a positive, so the answer is a positive. And here I'm dividing a negative by a positive, so here the answer is a negative. I remember what I wanted. I wanted it to be less than or equal to 0. That's our provisional problem we were trying to solve. So we are interested in these two sort of sides, these two parts of the real line, right? Remembering that this continues forever, right? One more problem to pay attention to. Since we have less than or equal to 0, we would be tempted to include both of these endpoints, but in fact we can only include one of them because the denominator of a fraction is never allowed to be 0. So I would be tempted, like I said, to do this and mark down all of that. But in fact, I cannot include the 4/3, the negative 4/3, because that would make the bottom of the fraction 0, and that's not allowed. So the solution instead will be closed in here, and then here open with parentheses. So not including the 4/3, and yes, including the negative 1/2. And if I want to write it out, I can say that the solution is minus infinity to negative 4/3 open, union, close the negative 1/2, plus infinity, open. Plus and minus infinity are always open, and then you decide whether other endpoints are open or not based on the other information you have. I hope this helps.